Section 14.1, Counting Technique, Part 2. Alright, so we're going to begin with permutation, and this is the important part, when order matters. Okay, so if you look at the top, we're going to review that a factorial, 4 factorial is known as 4 times 3 times 2 times 1, which gives us 24. So, looking at the permutation formula, we have n, which represents the total number of objects, r, the number of selected for an ordered list, and then those are the calculator instructions. So you will need to be familiar with all of these ways to find the solution. So know the formula, but also know how to use the calculator. So for this first example, 7 choosing 4, and on the calculator, or in the formula, that would be 7 factorial over 7 minus 4 factorial, which would be 3 factorial. So we would have 7 times 6 times 5 times 4 times 3 times 2 and times 1, all over 3 times 2 times 1. So we can simplify this. Sorry about that. And when we multiply 7 times 6 times 5, we get 840. Shh, Finley, shush. Okay, so you have to know what calculator you have and what you're working with, because this right here is the shorthand of it. But in the calculator, if you have a newer calculator, it's a little bit easier. But essentially what you need to do is you type in 7 if it's an old calculator. If it's a new calculator, you can go straight to math, probability, and then 2, and then just type in the 7 and 4. But if it's old, you have to type in 7, and then you're going to have this little notation just to assign that 7 is n, and then your r is 4, which again will give you 840. So make sure you can do it in the calculator, and you get the answer, or the answer you're supposed to get. So then for the next one, 10 choosing 3, you're going to do in the calculator 10 choosing 3, which is 720. And if I did the formula, I would have 10 factorial over 7 factorial. So I would multiply 10 times 9 times 8, which would give me 720. So let's look at an example where order matters, and we're going to need to use a permutation. So example 1, in a race with 10 contestants, how many different ways can they place first, second, and third? So order matters because there is order in first, second, and third. You can't have someone win first and get second. That specific spot and position matters. It's not just a group of 3 people. It's specified as first, second, and third. So the order matters. So we're going to use a permutation. So we have 10 contestants, and we are choosing spots for the first, second, and third. So we're choosing 3. And in the calculator, we get 720. Now, we can apply the counting method we've learned before with this as well. And some of you might like to do this in addition to, or just to verify, or even first. So we have first place, second place, and third place. So out of 10 people, we can choose 10 different people for first. Since someone wins first, we only have 9 people then left that could get second, and then so on. We only have 8 people that could get third. And when we multiply those numbers, we also get 720. So again, the counting method might help you. You might not need it, or it might just confirm and verify what you thought the permutation was. Okay, so if we had a little specification, part B, we have Speedy McSpeedster. He always finishes first. So now how many different ways can we have the contestants get first, second, and third? So I'm actually going to start with the counting method on this one to kind of help out. So for first place, we only have one person because it has to be Speedy McSpeedster. So then he's part of the 10, so that means we only have 9, and then we have 8 for third. And this gives us 72 options. Now, if we did the permutation, then we only choose these 2 spots, and we only had 9 people to choose from. So that would translate into a permutation of 9 choosing 2. And if you plug that in your calculator, you get 72. Example 2. You have available the alphabet blocks A, B, C, D, and E, and they are placed in a row. How many different arrangements could you have? Well, you have 5 blocks, and you have 5 positions. So that's going to be 5 choosing 5, which in your calculator will give you 120. So if you did the fundamental counting theorem, you would have 5, and then 4 spots left over, or blocks left over, and then 3 blocks left over, 2 blocks left over, and then 1 block left over. So this actually equals 5 factorial, which is 120. So when our permutation has the same R and N value, this is what happens. Now, the question is being asked, how many arrangements end in C? So, if we have a fixed arrangement of C, then we only have 4 spots left, and C is taken, so we only have 4 blocks left to choose from. And that gives us 24. So, that would look like, I'm going to do the box for this one, I didn't do it for the last one. So, if it has to end in C, there's only one option at the end. So then since C is taken, we have 4 blocks to choose from for the first position, then 3, then 2, then 1. And when you multiply these, you also get 4 factorial, which is 24. Okay, so how many arrangements have the form blank A, blank B, blank? So I'm going to start with the fundamental counting theorem here. 1, 2, 3, 4. Okay, so we know that A has to be second and B has to be fourth. So that's only 1 block that chooses it. So in forming our permutation, if we do it simultaneously, we have 3 spots left, and out of the letters A, B, C, D, E, we only have C, B, D to choose from, so that's choosing 3. So we have 3 that could be first, and then 2, and then 1. And this gives us 6. So again, notice how you can do the counting method in conjunction with. You could do it just to verify. You could not need it and perform the permutation, but it is great to know how to do both. Okay, so then we have it gets a little bit tricky. It says how many begin and end with a vowel. Now, a vowel in this case is going to be A and E. Now, here's the catch. It doesn't say begin with A and end with E, so we could have the first 5 start with A and end with E, or we could have it start with E and end with A. So, if we start with A and end with E, 2 spots are taken up, so that means that for our permutation we have only 3 spots left and 3 to choose from. But we also have another option, because we could start with E and we could end with A. And this is the same scenario. 2 spots are taken up, but 3 spots left. And these are both valid. So both of these permutations equal 6. And since these are both possible, what we need to do is we need to add them together. So our answer for this one is 12. Now, if you need to see the visual, think about it like this. This has to be a vowel, this has to be a vowel, and these are all the consonants. Okay? So out of the vowel, I have two options. So it could be A or E to begin with. And then if I choose one, I only have one left over at the end. And then for the consonants, I have 3 left, 2 left, and 1 left. And 2 times 3 times 2 also equals 12. Example 3. There are 6 different books arranged in a row on a shelf. How many different arrangements could you have? Well, if there's 6 books, we have 6, and we're choosing 6 because we want to use all of them. And this gives us 720 options. Now, in how many ways can 2 of the books, A and B, be put together? All right, so this is a little bit tricky. What we're going to do is we're going to count A and B next to each other as a single book. We can't ignore the fact that... I'm really sorry. We can't ignore the fact that they take a position. But since we're essentially going to glue them together and they have to be together, we're going to count them as 1. So that 2 books take up 1 space. So now instead of having 6 different spaces, we have 5. So this turns into, let's do it. We have 2 options again. We have A and B next to each other. So that means 5, choosing 5. And just like the other example we did, you could also have B and A put together. Did not specify what order they were in, which is also 5 choosing 5. So what we're going to do is actually get rid of that and sign, and we're going to add them together. And they each give you 120, so your answer is 240. So then, if you answer the question, in how many arrangements will A and B be separated? Well, if 720 is the total period, 240 represent them together, then if you subtract those 2 options, you get when they are separated, which is 480 possibilities.